Hi dears, we will start today the unit 1 of physical pharmaceutics 2, that is colloidal dispersion. So we will begin our lecture with a simple question that what happens when we add sugar to water? Yeah, everybody knows that sugar will dissolve completely in water, right? So that solution we are going to call as true solutions. Okay, in other hand we are taking a sand. Okay, so what happens when we add sand to water? Here sand does not dissolve, the particles are large and can settle down. So between a true solution and a coarse suspension there is an intermediate type of system is there. Okay, that system we are going to call as colloidal dispersion. So next we will see the term colloid. Okay, the term colloid has derived from a two Greek words, that is kola and idios. Kola means glue and idios means like. So colloid means glue-like. A colloid is a mixture in which one substance which has fine particles that we are going to call as dispersed phase and mixed to another substance which we are going to call as dispersion medium. So the particles of the colloid have a range of from 1 to 1000 nanometer in diameter. So the solution is called colloidal dispersion because the particles of solution do not mix or settle down. We can give the example of gelatin, acacia and rubber. So what is dispersion? Dispersion is equal to distribution of one substance throughout another phase. So the dispersed phase, here it's there. Dispersed phase means the substance present as small particles. Here the dispersion medium means the substance in which the particles are distributed. We can give fat droplets which is dispersed phase and water is the dispersion medium. In the case of milk, we are taking the milk, okay. In that milk, dispersed phase is fat droplets and the dispersion medium is water. Okay, so we'll be getting the colloids. So when the size of the dispersed particles is approximately 1 to 1 nanometer to 1000, okay, 1 nanometer to 1000 nanometer, that system we are going to call it as colloidal dispersion. Okay, so the colloidal particle size is 1 to 1000 nanometer. These particles are larger than molecules present in the true solution but smaller than particles present in the core suspension. So what is the importance of colloids in pharmacy? Because we know immersion, suspension, in future you are going to study the nanoparticles, liposomes. Okay, so for this, how does colloidal nature affect the properties such as stability, appearance, behavior in body? Okay, so when you study nanoparticles, liposomes and emulsion later, you will be repeatedly come across the concept that we are learning today. Okay. So first, now we know what is colloidal dispersion, right? Dispersion means distribution of one substance throughout the another. Components we have dispersed phase and dispersion medium. So the colloidal dispersion particle size is approximately 1 to 1000 nanometer. We have the three systems here. Okay. Two solution means colloid, two solution, colloid and co-suspension. So the pharmaceutical examples we learned emulsion, suspension, liposomes and nanoparticles. Now we just discuss what is true solution. The substance is dispersed at the molecular level. So the solute is going to dissolve molecularly dispersed in a solvent. So the particles are extremely small. Comes to the colloidal suspension, here the particles are 1 to 1000 nanometer. They are larger than molecules but smaller than co-suspension particles. Next one, co-suspension. Particles are comparatively larger and may settle down. So this is the free systems. Okay, now we will go for the types of colloids. This classification is based on the nature of dispersed particles. Here you can see we have the three types. Okay, so this is based on the nature of dispersed particles. How many types we have? We have the three types: multimolecular colloids, macromolecular colloids, and associated colloids. We'll see one by one. Multimolecular colloids. Here, the colloidal particles is formed by the aggregation of large number of small molecules or atoms. So, when multimolecular colloids will come, that time you can think many small molecules will join together and it will form a one colloidal particle that we are going to call as multimolecular colloids. Here the examples are gold salts and sulfur salt. Okay, so multi means you have to remember many molecules together. It is doing and forming the multimolecular colloids. Next comes to the macromolecular colloids. Here the dispersed particles are individual large molecules. Okay, so whose molecular size itself falls within the colloidal range. So you can think like one very large molecule we have. Okay, it behaves as a colloidal particle that we are going to call as macromolecular colloids. Example, you can give protein, starch, cellulose. Okay, macro means what? Large molecules behaving as a colloidal particles. Next comes to the third one, that is associated colloids. These are the substances that behave normal electrolytes at low concentration, but when their concentration reaches a particular level, then molecule aggregate to form large particles called micelles. Okay, so this particular concentration we are going to call as critical micelle concentration. What? Critical micelle concentration called as CMC. Example like soaps, detergents. So we can understand or remember like low concentration is equal to individual molecules or ions. So above CMC we are getting this micelles of colloidal size. So associated molecules are nothing but molecules associated together to form micelles. Okay. So first once again we'll see multimolecular means many small molecules we have. Okay. Macromolecules in that case one big molecule. And in the case of associated molecules we have the molecules so to form the micelles. Yeah. Next comes to the classification of dispersed system, which is dispersed phase and dispersion medium. So they are classified according to the particle diameter of the dispersed material. We have here also three types. Okay. So the first one, molecular dispersion. Here the size will be less than 1 nanometer. Particles are invisible in electron microscope, pass through the semi-permeable membranes and filter paper. And here the particle do not settle down on starting and undergo rapid diffusion. You can give example ordinary ions, glucose dispersion systems. Comes to the colloidal dispersions. Here it is 1 to 1 nanometer to 0.5 micrometer we can consider as a colloidal dispersions. Okay. So the particles not resolved by ordinary microscope can be detected by electron microscope. Pass through the filter paper, but which does not pass through the semi-permeable membrane. Particle made to settle by centrifugation and it will diffuse very slowly. So you can give the example colloidal silver solutions, natural and synthetic polymers. Next last, now we'll see the what is coarse dispersions. In a coarse dispersion, okay, if we are talking about a coarse dispersion, the particles are large enough that they may be seen under a microscope and usually have a tendency to settle down due to gravity. So the main characteristics of the coarse dispersions are these are the large particles as you can see here compared with your colloids. So the particles may be visible or detectable under microscope. Okay, you can see now. So particles have a tendency to sediment, that's we know suspensions. Particles may settle, right? So they can generally be separated by ordinary filtration. So this system is heterogeneous. These are heterogeneous, like suspension and emulsion we studied, like it is a biphasic liquid dosage form. Correct, no? So the suspension is solid particles dispersed in a liquid, and the emulsion is one liquid is dispersed as a relatively large droplets in another invisible liquid. Okay. This is what your coarse dispersions. Now we'll see characteristics of your dispersed phase. First, when we are talking about the particles size, okay, the color is of your dispersion is determined by your particles. It means deciding by your particle size. The wavelength of light absorbed by particle is approximately related to its radius. The larger the particle size, the shorter will be the wavelength of light transmitted. Here in the picture you can see if the particle is small to largest, okay, what is happening is that if it's smallest we'll call as solution, like true solution, it will be completely dissolved and small particles are there. And in the case of colloid, it is not a true solution but larger particles, okay, but not, it's a medium level. And when we are talking about the coarse dispersion, that is what suspension, the particles will be larger. Okay, so this is how the particle size is influencing. Next comes to the particle shape. It depends on the preparation method and affinity of dispersion medium. This influence the color of dispersion. Like we have the shapes, spherical, rods, flags, threads, ellipsoidal. Okay. And if gold particles, we have spherical and disc. If it is spherical, it will be red. Disc means it will be blue. Next, surface area. In the case of surface area, particle size small to large surface area, which is effective catalyst and which will enhances the solubility. And comes to the surface charge. Surface charge means you have to remember the stability concern. So positive means you can give example gelatin, aluminium. Negative means you can give acacia, tagagand. So the particle interior will be neutral and surface will be charged. Surface charge leads to stability of colloids because of its repulsions. Next, here you can see the entire classification of colloids. First one is based on the physical state of dispersed phase and dispersion medium. Next one, nature of interaction between dispersed phase and dispersion medium. Based on molecular size in the dispersed phase, based on the appearance of colloids, and based on electric charge on dispersion phase. Is very, very important. Okay. In the first case, based on physical state of dispersed phase and dispersion medium. Here it may come for 2 marks. You just have to know. In the case if the dispersed phase, dispersion medium, and they given the colloidal solution examples. If the dispersed phase is gas, dispersion medium is liquid, we'll call as foam. You can give the example of soap, soda, gas and liquid, solid form, cake, bread, and gas it does not exist. Okay. Liquid means emulsion like milk, cream, butter. Liquid solid means you can give example gel like curd, cheese, jellies. Liquid gas means aerosol. Solid gas, solid aerosol. Solid liquid, salts or colloidal suspension. Solid solid. We can give an example. Next, this is very, very important for 5 marks point of view, and alone it may come for 2 marks also. So based on the nature of interaction between dispersed phase and dispersion medium, it is classified into 3 types: lyophilic, lyophobic colloids, and association colloids. So we'll be seeing one by one. First we'll talk about lyophilic colloids. So the colloidal solution in which the dispersed phase has a great affinity for the dispersion medium. They are also termed as intrinsic colloids. See here you can see this point is very important. Dispersed phase has the great affinity towards the dispersion medium. So you have to know the meaning. Lyophilic colloids means lyo means solvent. Philic means loving. Okay, so together we can call these colloids have a strong affinity for the dispersion medium. In simple way, you can remember the dispersed phase like the dispersion medium. So it interactly strong with it. Because of this interaction, strong interaction, lyophilic colloids are very stable, more stable, self-stabilized we can call. And examples like starch, gelatin, protein, gums. Okay. So how you will remember? Lyophilic colloids are lyophilic, which is equal to loves the medium, dispersion medium. Next we'll go for lyophobic colloids. Here, colloidal solution in which dispersed fats has no affinity towards the dispersion medium. So, meaning lyophobic colloids, lyo means solvent, same, phobic means hating or avoiding. So here, these colloids have little or no affinity for the dispersion medium. So we can tell the dispersed particles do not have much attraction toward the dispersion medium. So they are comparatively less stable. They require stabilization to prevent the aggregation or coagulation. Example, you can give gold salt, silver salt, and sulfur salt. Okay, so lyophobic means how you remember? Which does not like the medium. We will see associated colloids. In the associate colloids, this associate colloids will also called as micellar colloids. Okay, so they are formed by substances that at low concentration behaves like ordinary molecules or ions. When the concentration reaches a particular level, the molecules will associate together. These molecules will associate together and it will form aggregates. These aggregates we are calling as micelles. Okay, here you can see. So for example, you can give soaps and detergents. It's at low concentration, individual soap molecules. Okay. As concentration increases, soap molecules is going to associate and it will form the micellar. So the concentration at which the micellar formation is taking place, we are going to call it as critical micellar concentration. So we'll recall what is lyophilic, so well loving and it having the strong affinity for the medium. Lyophobic, solvent hating, little affinity towards the medium. And association molecules associate and forms micellar above the CMC. Next we'll go for next classification, that is based on the molecular size in the dispersed phase. We have multimolecular, macromolecular as we discussed. Okay, in the case of multimolecular colloids, individual particles of the dispersed phase which consist of aggregates of atoms or small molecules having diameter less than 10 to 7 centimeter. The particles are held by weak van der Waals forces. Example, you can give gold soul, sulfur soul. Next, macromolecular colloids. The particles of dispersed phase are sufficiently large in size enough to be a colloidal solution. These are called natural polymers. You can give the example of starch, cellulose, and proteins. Next is based on the appearance of colloids. We have two, salts and gels. Salts means when a colloidal solution appears as a fluid. So the salts are generally named as dispersion medium. When the dispersion medium is water, the salt is known as hydrosol or aquasol. When the dispersion medium is alcohol or benzene, it is called as alcohol or benzosol respectively. Next comes to the gels. When a colloidal solution appears as solid, the rigidity of gel varies from substance to substance. Examples jelly, butter, cheese, curd. Okay, now we'll see the next classification based on electric charge on the dispersion phase. We have positive colloids and negative colloids. Positive colloids means when dispersed phase in a colloidal solution which carries a positive charge. Example, you can give metal hydroxides like ferric hydroxide, aluminum hydroxide, methylene blue salt. Okay. Next, negative colloids like when dispersed phase in a colloidal solution which carries a negative charge. Okay, here you have to remember the charge is carried by dispersed phase. Okay. So the example is like silver salt, copper salt. Okay, and This is the end of your classification of colloids. Okay, next we'll see general characteristics of the dispersed systems. Is already we discussed particle size. The defining character is the particle size of the dispersed phase, which ranges to 1 nanometer to 1000 nanometer. This size range is larger than the molecules in true solution, but smaller than that of particles in co-suspensions or co-dispersions. Next, heterogeneous nature. Although they may appear homogeneous to the naked eye, colloidal systems are inherently heterogeneous, consisting of two or more phases. Next one, light scattering. Colloidal particles are large enough to scatter light, a phenomenon known as Tyndall effect. This makes a colloidal dispersion appear turbid or opalescent when a beam of light is passed through it. So the true solution do not exhibit the Tyndall effect. Then comes to the Brownian moment. Brownian moment means zigzag motion. The dispersed particles exhibit continuous or random zigzag motion. Due to collisions with the molecules of the dispersion medium, this phenomenon we are going to call as Brownian moment, which helps to prevent the settling of colloidal particles. Next comes to the surface area. Due to the small particle size, colloidal systems have a very large surface area per unit mass of the dispersed phase. This high surface area plays a significant role in phenomena like adsorption and catalytic activity. Next comes to the separation techniques. Colloidal particles cannot be separated from the dispersion medium by ordinary filtration, but can be separated by the techniques like ultrafiltration or dialysis. Next, size and shapes of the colloidal particles. The size and shape of your colloidal particles, which influence the properties and behavior of your colloidal dispersion, comes to the size of the colloidal particles. We know 1 to 1000 nanometer, right? So we have the lower limit and upper limit. Lower limit is 1 nanometer. Below this size, the dispersed particles are essentially large molecules or small aggregates of molecules forming true solution. And upper limit, it will be the particles tends to settle under the gravity and form the core suspension. Below 1 nanometer means will called as true solution. If upper limit means coarse suspension or coarse dispersions. And comes to the shapes, we have spherical, rod or cylindrical shape, disc-like or lamellar, fibrous or thread, irregular shape as we discussed. So the method of preparation and the nature of the dispersed material often dictate the size, shape of the colloidal particles. So to measure, techniques like electron microscopy, such as we have scanning electron microscopy, that is SEM, and transmission electron microscopy, that is TEM, and dynamic light scattering DLC are used to determine the size, and sometimes we can also measure the shape of your colloidal particles. Okay, this is the major end of your major characteristics of the colloidal particles dispersed phase. So these are the techniques which we are used to measure. Okay, SEM, DLC. And properties of colloids. It is very important in the point of 10 marks and 5 marks. This we will see in the next lecture.